Lily, do you have it set to to auto join or something? Because the moment I have it open, you are logged in and ready to go. Makes you wonder if I actually set it up where you could log in first. Hmm. Just checking the emails, see if anybody has any more questions. Giving people a few more minutes to log in. Where is everybody? 2 minutes. 2 minutes to go, and we are going to get started. All right. Well, I'm not seeing any specific requests, so we are going to end up just kind of doing whatever I think we need to do. This might be just your private one-on-one session, so if you have anything specific you want to see worked out, we can do that too. Before this siren goes off, I'm going to go ahead and kill this alarm. Okay. Sixth period. Let's see how everyone is doing on the assignments for this week. That sounds like a plan. Maybe there's something that'll stand out, like everyone's getting this one wrong, and that'd be a better idea. Okay, well, the people that have already done their first quiz assignment seem to be doing pretty successfully. Let's take a look at that, though. Okay, I got some problems we can do. So I'm going to get a big picture of this. So not many people have gotten this one, but the fact that no one has gotten it right kind of makes it stand out. So if you're just joining us on the replay, what I've done is I've just gone and looked at the results from your assignment this week, and I'm pulling out the problems that no one is getting right. Now, that doesn't mean that everyone has seen this problem, so it's not like everyone's missed it, but the people that did get it did not do well. So let's go ahead and start by understanding what it's telling us. Making sense of the problem. Well, it just says solve for t. Okay. And I've got this giant pile of gobbledygook. So I can tell you right now what we're going to be doing a lot of is abstract reasoning. Math practice set number 2. We're going to be doing all sorts of inverse mechanics to get this to t equal stuff. So in case you did not understand the goal here, we want to get t by itself on one side of the equation. So it's t equals answer. So now the real question, the real problem, I would imagine one of the real issues with y'all is, where do I start? I mean, I got twos and t's and fractions, and I just, what do I do? Well, the beautiful thing about math is sometimes you kind of get choices as to what you want to do. I'm going to give you a hint, and I think it's super sneak and really clever. Okay, so this goes out to everyone that hates fractions. So when you have an equation like this that has just one random fraction thrown in, this is for you. Okay, so we've got 16 minus 2t equals 3 over 2t, and there's our fraction that's going to bother us, plus 9. Okay, so remember when I said we're going to reason abstractly? Well, anytime you multiply some number times 1, it's equal to the same thing. Yeah, I think that's a pretty standard deal. And anytime you divide something by itself is equal to 1. So these are basic principles, and one of them we're about to really abuse in a clever way. Okay, so let's just think about this fraction. I'm going to just take it here to the side. So we've got 3 over 2t. Now, what will be great? In fact, I could write this a little bit in a different way. You could imagine this as 3t over 2. Because it's 3 over 2. It's the same as 3 over 2 times t over 1. So that's 3t over 2. Now, what would be great is if we could multiply this numerator times 2. Because then these would cancel out. And we would no longer have a fraction. It would just be 3t. So we can do that. And here's how. We are just going to multiply everything by 2. So we're going to take this equation and we're going to multiply every single term by 2. We're going to multiply the 16 times 2, the negative 2t times 2, most importantly, our fraction times 2, and the 9 times 2. And what will happen is the fraction will disappear. So 2 times 16 is 32. Negative 2t times 2 will be negative 4t. 3 over 2, like I said, if we multiplied it by 2, the denominator and the numerator would cancel out because of this abstract rule. And we'll just end up with 3t. And then 9 times 2 is 18. So it's plus 18. I'm going to go on record again as saying that I hate using t as a variable because it always looks like a plus sign. Okay. And now there are no more fractions. Hooray. So that was for you people that hate fractions. You're welcome. Now we just need to do some more inverse math. And the rule we're using here mostly is going to be that, any value. Oh, I do my go back. I do all my laws in. No. Leave that. Okay. I want to draw in red, please. There we go. Okay, so any number being added to its opposite is equal to 0. So that's the rule we're going to be using here mostly. Okay, so let's go ahead and get all the t's on one side. So let's add 4t to this side and add 4t to this side. Now, nothing is going to tell me to do this. This is my intuition from having done so many of these problems. I want to have the variables on one side and the t's on one side. Not the I want to have the constants on one side and the variables on one side. Remember, the goal was to get t by itself. That means I need all the t's together. So if I were to add 4t to both sides, 3t plus 4t is 7t. 4t plus a negative 4t is 0, and that's the rule we were abusing. Okay, that's what we wanted. So now what we can also do is we can subtract 18 from both sides. So 18 minus 18 is 0. Make everything green again. And 32 minus 18, well, 32 minus 10 is 22. 22 minus 8 would be 14. Okay. So 7t is equal to 14. So now I can just divide both sides by 7. Again, using one of our abstract rules, because 7 divided by 7 is just 1. So what you end up with is just 1t, and 14 divided by 7 is 2. So it's official. We have t all by itself, t equals 2. And that's the answer. And that is a question that was posed to students in class and nobody got it right. That doesn't mean not many people got that one, but the ones that did, they missed it. So maybe it was the fraction that threw them, but that I've given this strategy on how to get around that fraction. Oh, you know what? Here's another one. Same situation, same lesson, same scenario. Of the people that got this question, nobody got it right. Let me show it to you. No, I don't need to save you. Feel free to sound off in chat if you have a question about something that's going on. Okay, so here we go. This is almost identical to the last problem we had, structure-wise. It's got a fraction thrown in. That could make things more difficult, but it really shouldn't, because there are ways to get rid of fractions. If you want to see why I'm doing what I'm about to do, rewind the video to what we just went over. And what I'm going to do now is use my repeated reasoning. Basically, the skill that just worked for me will work here because the problems are so similar. So here's the plan. To make this just easier on myself, because I like things to be easy, I'm going to multiply every single term on both sides of the equation by 3. And the reason I'm doing that is this fraction right here. If I multiply, again, I'll do a small explanation. This equation, this term, this expression can be written as 2p over 3. Now, if I were to multiply the numerator by 3, if I were to do that, if something were to allow me to, then this would cancel out with the bottom, making it a multiple of 1. It'd just be 1 times 2p. And then the fraction disappears. So what would allow me just to randomly multiply this one expression by 3? Well, as long as I multiply everything times 3, the equation will stay balanced. So that means if I want to multiply 2/3 p times 3, I need to multiply 5 times 3, negative 3p times 3, and 16 times 3, which I'm fine with because that gets rid of the fraction. Okay, so 3 times 16 would be 30 and 18, so it'd be 48. 3 times negative 3p would be negative 9p equals, and like I said, when we multiply 2/3 p times 3, it reduces itself just to 2p, which is what we wanted, no more fraction. And then 3 times 5 would be 15. So we just use a whole lot of abstract reasoning, and we're obviously persevering in solving this problem. I'm constructing the argument as I go to prove to myself that what I'm doing makes sense. I'm modeling with my mathematics. I'm definitely attending to precision because I don't want to make any mistakes. Okay. So now, so the structure that I'm going to be using is inverse operations. You might even argue that is a tool, but anyway. So I know that I want to get all the p's on one side of the equation and all the constants. Constants are the numbers that don't have variables attached to them. So, and I like positive numbers. Like if I were to subtract 2p from both sides, yeah, that'd be getting all the p's to one side, but it'd be negative. So just to engineer this so that I always have positive numbers, I'm going to go ahead and add 9p to both sides. Because if I add 9p, that means I'll have positive variables, and that's always good. I'm also, because if you look at it, now I'm going to have all the p's on the right side of my equation. So if I want to move my constants to the left side, what I've got to do is subtract the 15 and get it out of there. So whether you're adding or subtracting it, it doesn't really matter or is decided by, large numbers, small numbers necessarily. But I always want to try and engineer it so I have positive values if I can. So let's see. Pardon me. Okay. So certain things are going to cancel out. In other words, they're abstractly going to make zeros or ones in a later step. So 15 minus 15 is 0. Negative 9p plus 9p is 0. So what do we end up with? Well, 48 minus 15 would be 48 minus 10, which is 38, minus 5, which would be 33. So I've got 33 here, plus 0 equals 2p plus 9p is 11p, plus 0. Okay. Right now, you should start getting that good, comfy feeling because you know this is going to come out to be a whole number. That always makes us feel confident. If I divide both sides by 11, by abstract reasoning, this makes 1. So it's like 1p. That was the whole reason I did that. No one told me to divide by 11. My intuition from experience told me, oh, that's what I should do. So p is equal to whatever this is. 33 divided by 11 is 3. So there it is. So that's one of those questions that the people that got it, nobody got it right. Let's see if I can find one in the other lesson. So those are the 2 problems so far. The people that actually have done their work before today that showed me, hey, these are more difficult than the average. Let me go ahead and look at the other lesson and see if we've got similar situations. Hope everyone's doing well and everyone's families are safe and sound. Oh yeah, here we go. Okay. Not to cut from the serious subject to, the lighter side of math, but I've got a bunch of these that people are not doing well on, much more so than in the last lesson. The last lesson seemed to be a much higher success rate than these. Okay. So the one we are going to start with, 75% of the students that got this one missed it. Let me capture the picture for you. Bring it over. Okay. So I'm going to do a really thorough breakdown of what these A, B, and C answers mean. And then for the rest of these problems, I will not do as expanded an explanation. In a system with equations and lines, we need to talk about what this word means. The word solution. How many solutions does the following equation have? Okay, so at its root, here's what it's talking about. Start with the color purple. Actually, we'll start with purple. All right, so no solutions. No solutions happens when you have 2 lines that are parallel and they never touch. Because a solution is where the systems intersect. Okay? One solution is where you have 2 lines going in different directions and they actually have a meeting point. Maybe I should do green because I did a green box around the word solution. There you go. So these 2 lines, this system actually has a place where the 2 functions meet. And then you've got this really interesting situation with infinite solutions. Okay, now this one's hard to draw, but I'm gonna do my best. Infinite solutions is where you have two lines that are exactly on top of each other. They intersect always. So those are the visual representations of what these three answers mean. No solutions means they never cross. Exactly one solution means they cross one time. And then infinite solutions means that they're the exact same line and they cross each other always. Of course, the problem we're given isn't pictures. So we have to have a way to algebraically recognize these without having to draw a picture every time. And here's how that happens. So no solutions is when you get something, when you do all the breakdown, you end up with something like 7 equals 15. And you know that's not true. You know that doesn't make any sense. That's what it means to have no solutions, is you end up at the end of your work with two numbers that aren't equal to each other. It's just it doesn't work, right? Okay. Now, exactly one solution will end up with x equals a number, or y equals a number, or z equals a number, or whatever the variable is, will end up with x equals a number. And that is the x coordinate, that is the x value of the coordinate pair, or the y value of the coordinate pair, where these two lines do in fact intersect. So that's our signal that we found an answer, but there's only one of them. Now, the opposite of what no solutions looks like, what you'll get for infinite solutions is something like, I don't know, 24 equals 24. You'll get an equation where the two sides are the exact same thing, because 24 is always equal to 24. Get it? So that is the breakdown of the three different solution types that you are choosing from in this lesson. And this is what those three things mean. No solution means that the system never intersects, and the way it looks algebraically is having two numbers that just don't equal each other. One solution is where the two lines intersect in a system one time, and the signal for that is you'll get x equals number, or z equals number, or whatever. And an infinite solution is where the two lines are the exact same function. They overlap with each other, so their solutions are all numbers. They are always the same. Okay? And now that I've done the thorough breakdown, let's just check and see which one this happens to look like. So if I can just select all these, I think, oh man, it won't let me. Okay, so I'm just gonna have to clear these out and we'll work this from the beginning. Okay. So basically, I'm gonna take this equation right here, I'm gonna rewrite it and start combining some like terms. So negative 25z plus 1 plus 35z equals 10z plus 1. Negative 25z plus 1 plus 35z equals 10z plus 1. Yep, it's all there. Okay, so combining like terms. Well, this term and this term, they're both on the same side of the equation, and they both have the exact same variable to the same power. So I can combine them. So negative 25z and 35z, if you combine those, it's the same as doing 35z minus 25z. So that's going to be equal to 10z. And I still have the plus 1. And then I have 10z plus 1 on this side. And I don't have to do any more arithmetic. You might notice that both sides of this equation are the exact same. That means that there are infinite numbers of solutions, because on either side of the equation, they are twinsies. They are the exact same thing. So the arithmetic side of it is just inverse operations, combining like terms, just being a very precise mathematician. The answering side of this is understanding what these three options actually mean and what they look like. Let's try another one, because I've got a bunch over here that people did not really understand how to answer. No, I don't need to save. So the last one, 75% of the people that got it did not get it correct. This one, 0%. Nobody got this one right. I clicked the wrong button. No, I don't want to do that. All right, let me capture it real quick. All right, here it is. All right, so let's make sense of the problem real quick. How many solutions does the following equation have? Okay, so either no solutions, exactly one solution, or infinite solutions. And if you just join us in the replay, go back a minute and see my full explanation on the previous problem. Okay, so the first thing I want to do is type out this equation again. So that'd be negative 4x minus 7 plus 10x equals negative 7 plus 6x. Negative 4x minus 7 plus 10x equals negative 7 plus 6x. Okay. As long as I wrote it down right, we can continue. Negative 4x minus 7. I always triple check because I hate when I miss a question because I wrote down the problem wrong. Negative 4x minus 7 plus 10x equals negative 7. Yeah, okay. So now combining like terms, I've got a negative 4x and a 10x. These are both on the same side of the equation, and they have the same variable, the same power, so I can combine them. So negative 4x plus 10x, that's the same as 10x minus 4x. So that's going to be 6x. I still have the minus 7 equals negative 7 plus 6x. Aha. And hopefully some of you that are watching this will understand and immediately notice that these are the same thing. We can just use the commutative property of addition here. Again, that's us. That's a real quick abstract reasoning. The law says that if you're adding two things, you can change their order and you do not alter their value. So this would be 6x minus 7. And I'm going to go ahead and use the commutative property here and rearrange this. Instead of being negative 7 plus 6x, I'm going to have it be 6x plus negative 7. So, and this is the same as 6x minus 7. So they're the same. So again, this is an infinite solution answer because both sides of the equation are the exact same thing. Let's try another one. And no, I don't need to save. Actually, don't show me that message anymore. Okay. All right, here's the next one in the exact same skill set. Okay, so here's our equation. I need to know if it's no solution, exactly one solution, or infinite many solutions. So by this time, since I'm on my third problem, I'm just starting to use regular repeated reasoning, because now that I've done a couple, I'm just in the rhythm. I know exactly what I'm going to do. Step 1, rewrite the equation. 60z plus 50 minus 97z equals negative 37z plus 49 60z plus 50 minus 97z equals negative 37z plus 49. Okay, done. Next, combine like terms. So 60z and negative 97z have the same variable, same power, same side of the equation. So I can go ahead and combine them. Now, this is the big negative, so my answer is going to come in negative. Negative 97z plus 60z would be negative 37z, because negative 97 plus 60 is negative 37. I still have the plus 50. And this side has not changed. Now, I know what the answer is, but I'm going to do one more step just to prove to you why. So what I'm doing is I'm constructing my argument to prove to you I know why the answer is what it is. Okay. I'm already understanding this is going to be a no solution, but here's why. If you were to add 37z to both sides, and you're allowed to do that just because it's an equation, and whatever you do to one side, make sure you do it to the other side. Well, if I add 37z to both sides, that's adding opposites. That, again, that is an abstract reasoning that we've been using all the time. Anything plus its opposite is 0. So this goes away, and what we're left with is 50 equals 49. And that, my friends, is a no-no. Nope. They do not equal each other. And because they don't equal each other, that is a no solution. These two lines will never, ever cross each other. They are parallel. Okay. Well, I'm glad we finally got a different answer. It would have been boring if every single one of these was an infinite solution. Please sign off in chat or send me an email. Let me go ahead and check and see if I've gotten a specific request. Nope, not for these. I got some emails about other classes, but not for this one. So we are just going to continue right along. One second. Okay, next problem. Let me get rid of this one. Let me see. Let me get a good one. Oh, here's another one where absolutely nobody got it right. 0% got this one correct. Let's see if we can figure out what the problem is. Wait, I need to capture it real quick. Okay. So, yep, just like before, my brain, because now that I've done 4 or 5 of these, it's probably only 3, but my brain automatically assumes it's more. I'm already just repeated reasoning because I'm just in the rhythm. So the first thing I'm going to do is type out the equation again. So that's -9, parentheses, z plus 8, end parentheses, equals -9, z minus 72. So this one does have a little bit more work involved. It's not the end of the world. So the first thing I want to do here is distribute the -9 into both terms. So I'd end up with a -9z plus, not plus. -9 times z is -9z. -9 times 8 would be a -72. And this says -9z minus 72. And I instantly noticed negative 9z minus 72, negative 9z, they're the same. And if they're the exact same, that means they have infinite numbers of solutions because they're the exact same line. Okay, I think I'm going to do maybe one more, and we are going to call it a day. Let me see if I can get one that most people... Okay, so for this one, and it's the same. Twice as many people missed this as got this one right. Okay, so I'm gonna use my repeated reasoning because I've just done a whole bunch of these, and I'm definitely going to be attending to precision, make sure I'm not making any clerical errors. Making sense and solving, persevering. I'm not going to give up till I solve it. I'm going to be doing a lot of abstract reasoning when it comes to inverse operations. I have to prove, like, I don't want to pick an answer unless I've proven it to myself that the answer is correct, and I'm definitely going to be modeling with mathematics. I would say, I mean, this one can get a little tricky, like using the correct tools. I don't know. I think that the tools and the structure can be the equations themselves, but let's just go ahead and get to it. Okay, so I'm going to rewrite the equation. And this is what you would be doing on your own paper. I just type it because my screen is not paper. 13y plus 3 equals 13y plus 39. So 13y plus 3 equals 13y plus, okay, so there's that. So success. I've written down the equation. Step 2. Now in this one, instead of combining like terms, what I have to do is do the distributive property here and here. So that'd be 13y plus 13 times 3 is 39 equals, now the other side hasn't changed, it's still 13y plus 39. And immediately I noticed that 13y plus 39 is on both sides of the equation. Wow. It's amazing that every single one people are having problems with. This is just my teacher brain kicking in. It seems like the ones that everyone are missing are either no solution or infinite numbers of solutions. Somehow we have not had a single one, and we're talking about an item bank of over, they're like 50 questions. No one seems to be missing them when they come out to be one answer, but everyone is missing them when they have to do with infinite answers or no solutions. So it seems like maybe everyone just needs to brush up on what these terms, like what these A and C answers actually mean, because y'all are brilliant people, and it shouldn't be this way. We shouldn't have 0 people getting this right or 75% missing it. So if what I've had to say today hasn't been of much help, please email me with specific questions and screenshots. Join us in the stream for these live sessions if you can. And if you can't, I understand. You got business to take care of. So keep yourself safe. Keep an eye on your family. Make sure you're making your beds every day. And I will see y'all next time.